This is a tutorial on how to use the heat engine setup at Utah State University. This setup is used to perform a gas cycle using a piston cylinder system that can be compared to ideal gas calculations. Begin by turning on both the hot and cold baths and setting their individual temperatures. The cold bath temperature should generally be around 20 degrees Celsius. The temperature of the hot bath should be determined using calculations, but around 50 degrees Celsius is generally sufficient. Be sure to measure the volume of the tubes and canister to be accounted for during calculations. While the baths are reaching their desired temperatures, use the calibration curve spreadsheet to calibrate the pressure sensor. Begin by ensuring that the pressure fit coefficients in LabVIEW are set to form a linear relation, meaning that C1 equals 1 while all other coefficients equal 0. This ensures that the pressure reading in LabVIEW equals voltage during calibration. Open the clamps on the inlet to the piston cylinder system. Move the piston to the top of the cylinder and close the clamps to create a closed control volume. The set screw may be used to temporarily set the position of the piston, but be sure to release it prior to calibration or experimentation. Start the LabVIEW VI. Place masses ranging from 10 to 100 grams on the piston and record the corresponding voltages from LabVIEW in the calibration curve spreadsheet. After collecting calibration measurements, confirm that there is a linear relationship between voltage and pressure in the calibration curve spreadsheet. Enter the C0 and C1 values from the calibration curve spreadsheet into LabVIEW so that the pressure can now be read in pascals. The C0 value should be negative and the C1 value should be positive. The thermocouples, or the internal temperature probes of the hot and cold baths, may be used during experimentation to determine the temperature of the water. If using the thermocouples, be sure to use the red sheath thermocouple for the hot bath. After both the hot and cold baths have reached their desired temperatures, experimentation may begin. Be sure to keep both the hot and cold baths turned on throughout the entirety of experimentation. Remove all mass from the piston. Release the clamps and set the piston height so that it has ample room to rise 40 millimeters, but will not hit the bottom of the cylinder when mass is added. After closing the clamps and releasing the set screw on the cylinder, place the canister in the cold bath. After chamber temperature has stabilized and without mass in the cylinder, record piston height, chamber air temperature, and chamber pressure from LabVIEW. Add 50 grams to the piston to cause isothermal compression. Again, record piston height, chamber air temperature, and chamber pressure. Move the canister to the hot bath, causing isobaric expansion. The cylinder should be lifted about 40 millimeters. After chamber temperature has stabilized, record piston height, chamber air temperature, and chamber pressure. Remove the 50-gram mass, causing isothermal expansion. Record piston height, chamber air temperature, and chamber pressure. Move the canister to the cold bath, causing the piston to lower to isobaric compression. The system should be in its original state. After chamber temperature has stabilized, record piston height, chamber air temperature, and chamber pressure. Due to air leakage, the piston will likely not return to the same spot on the cylinder. To quantify air leakage in terms of volume per unit time, place a 50-gram mass on the piston and record the change in piston height after 5 minutes. Use this information to correct measured data. To do this, you will need to reperform previous steps while recording the time at each point measurements are taken. Perform the cycle 5 times or as many times as possible to increase the reliability of measurements. After experimentation is completed, turn off both water tanks.